Today's problem is maximize the minimum difference between k elements, difficulty, medium, accuracy. Wow. Whew. Really high. Given an array of integers and an integer k, select k elements from the array such that the minimum absolute difference between any two of the elements is maximized. So the minimum is maximized. Return this maximum possible minimum difference. All right. We need an example. All right, so we have an array here, 2, 6, 2, 5, and k is 3. We need to select 3 elements and maximize, right? Maximize the minimum difference, all right? Selecting 3 elements out of 4. What if we selected 2, 2, and 5? Well, then the minimum difference is 0. It's pretty low. What if we selected 2, 5, and 6? Then the minimum difference would be 1. All right, so that's what we have. Now this one, it's a little harder to see with the unsorted array, but yeah, if you selected 0, 4, I mean, you don't want to select things like 0, 1, 2, 3, 4, things like that, because then you're going to get a minimum difference of 1. But if you selected 0 and 4 and 9 and 13, then the minimum difference is 4. And that is the largest minimum difference possible. All right, array size is between 1 and 10 to the 5th, 100,000. The array elements are between 0 and 1,000,000, and k is between 2 and the array size. So I'm thinking the array size actually has to be at least 2 rather than 1. Time complexity, n log n. Yeah, I suppose so. Binary search. All right. Well, I mean, let's see what we can do with this. I would like to scoot this over a little bit and get everything. All right. We're going to need to sort the array. That'll be the first thing. All right. So let's go ahead and do that. Let me get a pen. I'm going to use the second element here as the example. Is this going, you know what, I'm not sure I even want to do it that way. I don't want to do it that way. I want to use the other pen. Let's do this. Okay, so let's sort this array. 0, 1, 2, 3, 4, right? 2, 3, 4, 0, 1, 2, 3, 4, 9, 13. Is that right? 1, 2, 3, 4. There's 7. Okay, and then 9, and then 13. All right, arrays, sort, done. N is the length, low. Okay, so we want to make an observation here that the maximum difference would be between the first number and the last number. So that is 13. So that's really our search space. Okay. It says somewhere between 0 and 13. So low is 0. High is the last number, 13, minus the first number, which is 0. So well, yeah, low is 0, high is going to be 13. Actually, let's just go ahead and write that. It's 0. Result is 0. While, oh, yeah, I can still scroll this though. But you know what? Now I've got this not really where I want it. Let's do it like this. I actually want to scroll this a little bit higher. Be better to scroll it like that. Yeah. Okay, let's do it like that. So we're starting out with result as 0. Result is 0. Result is 0. Low is 0. High is 13. Let's just go with that. And now we are going to drop into a binary search. Mid equals low plus high minus low divided by 2. So that's 13 divided by 2, integer division. It is 6. All right? If can select k. So we're going to see if we can select k elements, and k in this case is 4. Can we select 4 elements with a minimum difference of 6? Well, obviously not, but well, let's see what happens. Can select, so we go in here, count is 1, last selected element is array at 0, which is 0. For I equals 1, I is 1, so that's going to be here. Is I less than array? Yes. Is array at I minus the last selected element? That would be 1. Is that greater than or equal to the minimum difference? No. So that doesn't help us. So then we go to 2. Now, I can probably save a little time here. There is not going to be anything that's greater than or equal to a min diff of 6. So this is going to fall out of here and return false, that we cannot select 4 elements with a min diff of 6. All right? So this, on line 13, is going to be false, in which case we are going to set high to mid minus 1, and that is going to be 5. All right. Back to the loop. While low is greater than high, low is still 0. High is 5. Mid is low, 0 plus 5 divided by 2. 5 divided by 2, that is going to be 2. Okay. Can select. Array, we're going to send in a 4 and we're going to send in a 2. All right. Count is 1. Last selected element is 0. I equals 1. Is array at I minus the last selected element, which is 0. Is that greater than or equal to min diff? No. All right. Now we'll go to I is 2. Is 2 minus 0 greater than or equal to min diff? Yes. All right. So count, we're going to increment it. Count is now going to be 2. And the last selected element is going to be array at I, which is 2. All right. Go to the next element, 3. What about 3 minus 2? Is that greater than or equal to min diff? No. What about 4? Is 4 minus 2 greater than or equal to min diff? Yes. So we'll increment the count. It's 3. And the last selected element will be 3. Okay. Wait. No. I'm sorry. Not 3. It's not 3. It's 4. 4. All right. Go to the next element. 9 minus 4, is that greater than or equal to min div? Yes. Increment the count. That is 4. Last selected element is 9. All right, so we've actually gone far enough here to see that this is going to return true, that we can in fact select 4 elements with a min diff of 2. So we'll go back up here, line 13. Is this true? Yes. Result is mid. All right, so that is going to be 2. But we don't stop here because we might be able to get something better. Low is mid plus 1. That is 3. All right, so we're going to go back through the loop here. Low, I need to erase some things here to kind of start over. Let's erase all of these. Can we do that? We can't? We have to erase them one at a time? Or what is going on here? Oh, I see. Never mind. I see what the problem is. Let's erase all of these. Let's erase this. That can stay where it is. These, we're going to erase those. So let's see. Result is mid, low is 3, high is 5. Yeah, that's fine. All right, we're going to go around again. Low, is low less than or equal to 5? Yes. So we will take low, 3 plus high minus low is 2, 5. 5 divided by 2. Whoa. Wait a second here. Low plus, oh, I see. High minus low, which is 2 divided by 2. Okay, so it's going to be 4. It is going to be 4. Okay, get rid of that. 4. All right. Now we're going to call select with the array with k equals 4 and with mid equals 4. Come in here, count is 1. The last selected element is the first element, which is 0. And then we'll start at 1. All right. To save a little time here, it's not going to surprise you to learn that these are all going to fail until we get to 4. All right. Now 4 minus the last selected element is in fact greater than or equal to min diff, which on this call is 4. So we'll increment the count. It's going to go to 2, and the last selected element will become 4. Okay? Next element is 9. So we'll go through. This is array at I, which is 9 minus 4. Is that greater than or equal to min diff? Yes. So we'll increment the count and set the last selected element, which is now 9. All right, increment I again. That takes us here. Is array at I, which is 13 minus 9, greater than or equal to min diff? Yes. Increment the count. 4. All right. And we're done with the for loop. We drop out of here and we say, is count greater than or equal to k? Is 4 greater than or equal to 4? Yes. So this is true. And so we'll set result to mid. Mid is 4. right? So it's not 2 anymore, it's 4. Low equals mid plus 1, that is 5. We're going to go through this again. We're going to go through can select with 5. Now, spoiler alert, it's not going to work with 5. We can't select 4 elements with a min-diff of 5. So that's going to fail. And at that point, the low and high pointers will cross, and we will stop, and we will return the result, which is 4. Okay, so to kind of recap this, what we do is sort the array. We look at what is the maximum possible difference, and that would be the first, the last element minus the first element. And then we start doing a binary search. That is, we look in the middle. Can we select K numbers with that middle target as the minimum difference? And we keep doing the binary search until we converge on the maximum minimum difference, okay, within the search space of last element minus first element. So that's it. Let's get rid of the annotations, and let's just compile this as kind of a sanity check. All right, that worked. And then submit. Okay. Please like the video if you liked it, or, even if you didn't like it, you could like it. There's no problem with that. If you subscribe to the channel, which is free, I will send you problems of the day every weekday in your inbox, and we will see you next time.